Okay, I think we have met one time previously. We did circuit theory lectures, and today we are going to have the different type of lecture series. Maybe actually your module is that basic electronics for the chemist, but anyway, I am covering this digital electronics parts. I think already analog electronics section has been started and going on. Okay, then, sir, maybe different experience to you. I think we have discussed about circuit theories, and those things are maybe there's some kind of theoretical aspects we have discussed. And I think when you start this module, this basic electronics module, then there you have already identified two sections are there. One is analog electronics, the other one is digital electronics section. Okay, I think this may be the most easiest part that you are going to learn. I think some of you might already have some kind of experience with these things. Okay. Sorry for the disturbance. I think I was disconnected. The problem may be from my side, that network connectivity may not be good today morning. Let me have a minute to check that one. Maybe SID4G 6. Maybe okay. Shall Okay. Okay, then when it comes to the digital electronics, I think I mentioned that this may be the easiest section to you. Most of the time that it may be that you might have certain experience with digital electronics in your A level stuff, and in addition to that, sometimes that you might have the personal interest and this electronic kind of things, the making of circuits like that. But anyway, we are starting like our all the previous modules. We are starting from the beginning, and from the scratch, we are building up all these things. Because of that, you might not have any difficulty when you follow this module. And here we have 6 lectures, then basically 12 hours. Then after that, we have a tutorial also. Okay, when you come to the subject, what do you think about this digital electronics parts? Have you heard about these things, and have you used digital products? And maybe what do you think about this digital products before we go into the subjects? What do you think about the products, digital products? Do you use digital products in your day-to-day life?
Yes, sir.
Okay, then I think maybe all of you are having experiences using mobile phone. Okay, then your mobile phone is a digital product. What else?
Wi-Fi routers.
Yes, mobile phones, Wi-Fi routers, and you look around you at your home front that you have maybe LCD TVs or whatever the digital TVs in your living space, and maybe that you have digital remote controller for most of the devices you are having. And when you have washing machine, then the washing machine controller is a digital. And when you come to the refrigerator, most of the newly coming refrigerators are having digital interfaces that you can see the inside temperatures of these things, and some of the controllers are again digital. The previously we had certain knobs to control the temperature, but the modern refrigerators are coming with certain kind of digital controls. And what else? And other than your mobile phone, and you have laptop and desktop or whatever the thing, computer is a completely digital product. Mm. And when you go outside, then when you go to the bank, and most of the systems that today that are all of the banks that they are having uh, computerized systems, then a lot of equipment are there. And when you go to a hospital, again the lot of medical equipment, they are digital. And maybe airport and whatever the place that you name it, there we can find a lot of digital products. It indicates what? Most of the time, we like to bring digital products to our life. Or maybe because of that, the advantage or maybe the certain other features we can find out with these digital products, this may be helpful for our life. Because of those reasons, and day-to-day life, in our day-to-day life, we use these products. Okay, I think if I ask a different question, then if you are using these digital products, what do you think about that? Do you like those things? Do you like those products? And we have certain experience at using of these digital products. And when you use these things, and you might have identified certain features of these things, because of those features and because of certain advantages and because of certain kind of different other effects, you may like to use those. Can you tell me that one or two features or maybe the advantages, or considering that in your life, and why do you use these things?
Because they are easy to handle.
Yes, uh, we can write these things, and
Saves time.
easy to handle and saves time. Saves time maybe that when you use those things, you might uh, realize that certain features that you can do, certain features are helpful you to do certain things and very quickly. Not like can you give me a minute? Sorry for the okay, easy to handle and saves time. Sorry for the disturbance, and help us to access new knowledge very easily, and maybe brings easiness to life, maybe, and low probability of having errors means that we can say in different manner. We can say it's a high accuracy, and yes, increase accuracy and efficient. It saves lot of space as well. For instance, we can store a lot of data in e-files. Yes. Easy to store, maybe store means that the data we can. Then we can put these two things together and compact. Compact means the size may be compact, the size small in size, and other thing that's as you mentioned here. And when we want to store more information there, that much more information, we can put a very small area and easy communication. Maybe here we can see that. Okay, anyway, that why I put this question mark there is communication. And sometimes that we might feel certain difficulties because of the some kind of environmental conditions and different other aspects may be there, different other conditions may be there applied here. But anyway, that when you consider the accuracy of the devices, it may be very high. Okay, we can discuss a lot more things. And what about that? Some other important feature we haven't discussed are the thing that about the power. You can say low power consumption. And what about the cost? Okay. What about the cost? Again, it's low cost. Because if the devices are not low cost, whatever because of many more features may be there and many more advantages may be there. But if the devices are not low cost, then most of the time we might not take those things. But for that, accommodation is one thing that we can't accommodate, we can't afford to buy those things if it is not low cost. Because most of the things are low cost. Okay, I think these features are enough to have some kind of idea about these products. Okay, and with all these products, what do you think about that? What is the secret behind this one? How these digital products are giving this much of benefits, this much of advantages, maybe these features? How? What do you think? That's what we have to discuss. Actually, your subject is starting from that point onwards. That how can we, how these digital products can give this much of things to our life, and over analog products, how these are good? That is the question. Okay. Before I ask that question, can I ask a different question for the moment? I think with your experiences and when you look at the your surrounding and all the environment and all these things for the last couple of years, you might have realized that how these digital products are growing fast, how these digital products are coming into the market very rapidly, and how these products are coming into our home front, maybe some other places, that how these devices are spreading throughout the world, how fast it's happening. You might have some kind of understanding about these things. With that understanding, what do you think? One day, can we totally eliminate all other electronic products using this digital system? For example, that maybe the couple of years back, you might have a CRT kind of TV at your home front. But now most of you are having replaced those things by LCD or LED TV. And when it comes to your computer monitor, I think most of the time these days that you don't have the CRT kind of monitors. You have LCD displays, LCD monitors. And I think definitely you might not have experience using analog mobile phones. A couple of decades back, we had that experience. And it's a mobile phone, those are analog mobile phones. It's maybe size maybe something like a brick. Okay. Other than taking a call, you can kill a person by using it. Okay, it's a size is very huge and bulky and very heavy. But today you have very small, handy mobile phones, and if you want that, you can have the large screen mobile phones also. But again, that those things are giving some kind of idea to us. This replacement, the rate of replacement analog products, and we are all the time. If it is possible, we remove analog one and put a digital version. What do you think that one day can we totally eliminate all these things and maybe all the things may be digital? What do you think? Yes or no? Can we replace everything? Or maybe we cannot. What do you think? Okay, don't think too much. I think the answer is no. Why? Why? Why can't we replace everything? The simple answer is no. Why? In simple terms, the whole world is analog. We are analog. Okay? We are analog. Because of that, we can't replace everything. Okay. So the classic example is your mobile phone. When we talk, okay, our voice is analog. In your mobile phone, your analog voice is converted into digital, and through the communication channel, whatever the communication channel, wireless or wired communication media, and it sends to the other end. At the other end, your friend is there and he is listening. Can he understand that the digital voice, the digital sound, the digital signals? No, we have to convert those things back into analog. Then only that person can understand what we have mentioned here. Then, because of that, we have to go to the digital world. Why? Because of certain benefits are there, certain advantages are there, certain easiness is there, and certain accuracy is there. And we can do lot more things in very efficient and accurate manner. Because of that, we have to go there and use those things and come back to the analog world. There is an interface between the digital world and the human. Why? Because all other parts of the world is human. Because of analog. Because of that, this should be there. But what do you think about that? Your parents' love? Is it digital? Yesterday you don't have that, today you have. Your one may be like that, but your parents' love, not. But what about that? When you look at the outside of your window, you can see that wind is blowing, trees are waving, and birds are flying. All these events are analog. Because of that, the whole world is analog. Okay. Then we have to go to the digital world and feel the difference and do whatever the thing you need. After doing that one, having that advantages there, come back. That understanding should be there. Okay. Otherwise, that the technology cannot do everything without that involvement of human being. The number one is human being, and we have to care about the environment and all these things. We cannot survive if we destroy the environment. Because of that, the important thing is environment. Environment is totally analog, and we can do whatever the thing with the technology, but keeping all these things in safe. That's what we have to understand. Okay, come back to the lecture. Then how can we see these digital products are giving this much of advantages? The reason is that all digital products are based on logic states. Okay, they are based on logic states. Then how many logic states are there? We have only 2 logic states at the moment, but 2 logic states currently. But however, when we have this first experience of these digital systems, actually the US Navy during the World War II, they have introduced this system to the world. They have invented this one. With their system, they had 10 logic states matching with the decimal number system. You know that with decimal number system, we have 10 digits, 0 to 9, to match all the things. With these digital systems, they had 10 different levels. Why that? We want to send their secret codes to their messages to the different places using a secret code. Because of that, they use 10 different voltages, 10 different voltages to represent those numbers. Then they can send their things to different places, the remote places. That's how they have started this one. But today, with the understanding of this, maintaining of these 10 state logic levels is a quite different one. Even that the maintaining of these 2 state logic also quite difficult. Because of that, people have realized that one. Because of that, we use today this 2 states logic. Okay, it may be high low, then you can say high low, or maybe you can say on and off. You can say true false, and if you want that, you can use white and black. You need here. We need 2 extremes, 2 different things to represent this 2 state logic. Otherwise, that there is no meaning that when we say high, low, on and off, true, false, white, black, like that. But whatever the thing you can use, only the thing, these are the representative words. We have 2 logic states, and we need 2 different names for these ones. That's it. Okay. Now we have realized that based on these 2 state logic, everything has been built up. Okay. Then I think how can we make circuits at all, saying that we have 2 state logic? Now we have to collect different tools to be used with this 2 state logic. Then only we can make circuits. Okay. Then only we can make circuits, and we have to collect different tool sets. And first important thing that we have to identify, we have to bring a certain number system to be used with this two-state logic. I think number system, we need a number system. And what is the current number system we are using? What is the day-to-day life? What is the number system we are using? Okay, many number systems are there.
Indo-Arabic number system.
Yeah, in our day-to-day life, we are using decimal number system. Decimal number systems, their base is 10, and the digits we are using 0 to 9. Those are the digits we are using. Okay, then base is 10. Okay. What are the other number systems we have? The octal number system. Octal number system, then base is 8. The digits we are using 0 to 7. Okay. Then other one, binary number system. Binary number system. Then with that, base is 2. And then digits we are using 0 and 1. And there are some other, and you can say hexadecimal. Hexadecimal number system. Then their base is 16. And digits we can use that we need 16 digits. Then it may be 0 to 9, we have 10 digits there. 9, then we need another 6 when we are taking first 6 letters of the English alphabet, A to F. Okay, but here that you can see what is the best match with our two-state logic. It's binary number system. Okay, binary number system we can take. That is the best one. Here we have 10 state, and we can't use this one. This is no, but this is the good one. Then we can take this binary number system here. Binary number system. And we base is 2. Then binary digits. Binary digits we have 0 and 1. But hereafter, we don't say that these are binary digits. We say it bits. Okay, and you can say bit. When you say bit, 0 is a bit, 1 is a bit. Okay, then we have selected binary number system here. binary number system. Then we know logic states, but not only this, we need a kind of algebraic methods here. We have to use some kind of mathematical operations with these systems. Because of that, we have to select uh, a kind of mathematical operations to be used with these circuits. Then, but our day-to-day life, that what are the mathematical operations we are using? That we are using addition, subtraction, multiplication, division, like that. Those things are. But straight away we can't use those things with our two-state logic. Then we have to find a different one. Then the actual solutions we can take from Boolean algebra, but actually we are not going to learn about Boolean algebra. But if you are going to learn Boolean algebra, it might take another 1 or 2 years, the entire thing. But we are taking some kind of, sorry for that unstable connection. We are taking some kind of concept from this Boolean algebra. Okay. Then what are those concepts? We are taking first thing Boolean variable. We need this one. What is Boolean variable? If Boolean variable is A, if A is the Boolean variable, A can take two values, that is 0 or 1. Okay. If B is Boolean variable, B also can take 0 or 1. Okay. But in Boolean algebra, it says true, false. But hereafter, we don't say true, false, but we say 0 and 1. Okay. It's actually the other way around. Can 1 and 0, that's true and false, like that. Okay. But when we take those things there, we have this A. A is a Boolean variable. When A is 0, we say it's A bar. Okay. When A is 1, we say it's A. Okay. Because A can have only two values. A may be 0 one time, A may be 1 one time. When A is 1, we say it's A. When A is 0, we say it's A bar. Okay. The other one, and we need some kind of mathematical operations here. Then instead of using mathematical operations, and we are taking some kind of Boolean operators. Boolean operators. And when I say Boolean operators, and I think you have maybe heard about this one many times. Then these are the Boolean operators we are going to take from Boolean algebra to be used with our digital circuits, not O and the no opposite of O, the NAND and exclusive O. These are the 6 basic operators we are going to take from Boolean algebra. Okay, I think some of you have learned about these things and you have worked all these things also, but anyway, we are taking those things from the beginning. And you know that we can apply this Boolean operators to this Boolean variable. Okay. For example, if you want to apply this not operator, when we apply this not operator to A, then result may be A bar. Okay. Then we can take AND operation between two variables like that. Okay, we can do that. But anyway, that on a paper, we can do this. But when you want to make a circuit, okay, when you want to make a circuit, then we have to have a circuit, some kind of the different circuit, the practical circuit modules. That you know that circuit is a collection of components. There may be resistors, capacitors, transistors, diode, like that. We need actually in practical manner, we need some kind of electronic circuits to do this operation. Okay, because of that, we have developed different electronic circuits to do these Boolean operations. Okay, those circuits we call they are logical devices. This name, I think you may be familiar with this one. Logic gates. Okay. Most of the time that you have learned about these things in many places, but to have a complete understanding and complete note, okay, we can start learning those things one by one, taking. First, we can take NOT gate. When you consider about whatever the electronic circuits, we need three things there. Okay. First one is a logical symbol. We want to represent this. The second one, the truth table. The truth table explains the whole function, the whole behavior of the circuit. The third one, notation. Okay. For this NOT gate, this is the circuit symbol. It's having single input. We can say it's A, then output is F. The notation is F equals A bar. Because when you give A here, you will receive A bar from the other end. Then the truth table is A can have two values, 0 or 1. Then when you give 0, output will be 1. When you give 1, output will be 0. This is NOT gate. The next one, O gate. Okay, okay, it is this NOT gate is having only single input and single output, but O gate is a different one. It's having two input minimum. Maximum there is no limit, but minimum we need two inputs. You can take A, B, and output is F. The notation is F equals A plus B. And to table, when you have two inputs, you all know that we have four combination. When A is 0, B may be 0, and B may be 1. When A is 1, B may be 0, or B may be 1. These are the four combinations. For these combinations, O gate provides this type of output. Okay. What's the meaning of this one? In whatever the input is true, whatever the input is 1, it produces 1 as the output. Okay. Okay. Then the other one, AND gate. AND gate is also, it's having 2 inputs minimum. And there is no maximum limit practically. Practically we have a limit, but theoretically we don't have maximum limit. The notation is F equals A dot B, or you can write it without having dot also. The truth table is zero, 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 one. Why? And provides output 1 when both inputs are true. When both inputs are 1, 1, then only N provides output 1. Okay. Then other one is no gate. The no is not a new one. Actually, it's a combination of O plus not gate. Is actually completely opposite of O gate. Example, if you can draw O gate like this A and this is B, and we have this small circle in front indicating it's not like the simple idea is this. We have this is A and this is B. Okay, and this is F. After receiving O function, we will send it not gate. Then O will be inverted. O result will be inverted from this one. Okay. The notation is, you know, that this is O And we have sent it to NOT gate. That's why we have this stop bar. Truth table is completely opposite of O gate. O tells us when any input is 1, output is 1, and this one is opposite of that. And this should be 1. This is 0, 0, 0. And compare this one with the O result. O is 0, 1, 1, 1. No is 1, 0, 0. Completely opposite of that. The other one is NAND. NAND is also N plus not. That is NAND. Then notation is this is N and this is NAND. Okay. Truth table is the opposite of AND gate. N provides that 0, 0, 0, 1 here. Because of that, this should be 1, 1, 1, 0. Okay. NAND is actually the combination of AND gate plus NOT gate. This F. Be like this. I'll turn off the camera because that maybe the bandwidth is not enough to cover the video. And final one is exclusive no. Exclusive O. And this is its notation. You can see the difference between O and exclusive O symbol. And truth table is this. Here it's 0, 1, 1, 0. Okay. then what actually these truth tables are telling us? When you come to this O gate, what is the meaning of this one? What is the actual meaning? When you want to check that, you can assume that there are two doors. Okay. For example, assume that here we have a maybe small room, something like that, and you have two doors. One is A, the other door is B. We assume that we have fixed two sensors there to check whether the door is open or closed. Then if you want to check if one of these doors are open, if one of these doors, then definitely you have to use O gate. Why? It checks only any of these conditions, one of these conditions are anyone is true, then it gives one. Okay. But if you don't want to check both things at the same time, then the option is O. But here, what about this gate? This one, it provides one when both are satisfied. You can see that the meaning of AND is something like that. You and I. Then when I say you and I, then both have to go. You and I, when both of us, you and I go there means both have to go there. But if you say you owe me, then there anyone needs to go there. That is enough. Simple meaning. But this exclusive O is different one. With this exclusive O, what can we do? What type of thing we can check with exclusive O? Tarusha, what do you think? And if when you want to check, both inputs are not equal. You can see it gives one when both inputs are not equal. But when they are equal, it gives 0. When they are 0, 0, output is 0. When they are 1, 1, output is 0. But when those inputs are not equal, sorry that I think I was disconnected. This problem, I think we have to face it all the time. I think most of the time that for one tower, many people are joining. Because of that, the towers are overloaded during this, especially that these time bells. Okay, I think now we have covered many things that when we start from the beginning and we had idea about this logic states. Then after that, we identified a number system to be used with this logic states. That is binary number system we have selected. And we wanted to have some kind of mathematical operations to be used with this one. Then we have get some ideas from Boolean algebra, then Boolean variables concept we board here, and then we have to discuss about the Boolean operators and why. Because we want to make circuits and we need some kind of algebraic operations to be done. Then we took some kind of ideas from these Boolean operators. Then for these Boolean operators, we developed kind of practical, physical electronic circuits. Those are logic gates. And we have discussed about these 6 basic logic gates. Now, what is our aim? What is our final aim? To design a digital circuit. In other words, to become a digital circuit designer. Now you are ready to do that. Do you? Do you have that confidence? Are you ready to start designing of digital circuits? To become a digital circuit design? What do you think? Okay, then shall we face that challenge? Okay, before we do that one, maybe can we do small exercise? Actually, Sasvika, that we can't have more than 2 inputs for exclusive OR gates. Okay, but if you want more inputs for exclusive operations, what you can do is that you can combine exclusive OR gates, something like this. Now here, from this end, what do you have? You have exclusive OR from this one. Then if you want to have another one, then you can take another variable like C and combine with this one. Then this will be A exclusive OR B exclusive OR C. Is it okay? Okay, welcome. Okay, then before we start designing circuits, I think we have to have this type of experiences all. What do you mean? And we have to design circuits. Before we do the designs, what can we do? And we have to have some kind of experiences of drawing circuits like this. Okay, for example, I'll draw this circuit. Maybe I put NOT gate here. Then what is the output of this NOT gate? Is A bar. Okay, again I have another variable here is B. From this B we are taking here, and I put AND gate here, and maybe another variable C is here. Then I put another AND gate. Then what is the output of this one? C bar. Then I'll bring it here. Then what is the output of this one? Then AND operation between B and C bar. It should be BC bar. Then after that we can take OR gate. Shall we bring this one here and this one here? Then what is the output of this one? This function of this gate is taking operation between this input and this input. What is this input? Is BC bar. This input is A bar. Then we write this is the one input. The other input is BC bar. We are taking operation in between these two. Okay. Then shall we write output equations for this type of circuits first? I draw some circuits and you can try to write output equations for those circuits. Okay. then A, B, C. Okay. This is first one, second one, third one,
Excuse me, sir.
Okay, you can see the first one. I'm sorry that I didn't see that. You have requested to see the first one. Here, what we have done is that when you consider this NOT gate is providing all the time the whatever the thing coming is get invert. Because of that, it's A bar. Okay. Then here, when you think about this gate input, this is B and this is C bar. So function of this gate is taking AND operation between these two inputs. Because of that, it comes as B C bar. And here we have A bar and this is BC bar. Then the function of this gate is taking whatever these two inputs. One input is A bar and the other input is BC bar. We are taking O between A bar and BC bar. You have to consider this one as one entity. It's not two different things. Now, after coming out from this gate, this is one thing. It's not two separate letters, two separate variables. This is one thing. Okay, here, then this is A and this is B. Because of that, this is A plus B. And the function of this one is whatever the input is coming to as the input, it should be get inverted. Then this is A plus B bar. And when you consider this gate, this is B. Because of that, here we have B bar. This is C. The function of this one is taking O between these two inputs. Because of that, it's B bar plus C. It's coming here. Then this one taking AND operation between, this is one input and this is the other one. Let's see. And taking AND operation between these two. First one, I think here it is not necessary to put a bracket. Because when we say B, C bar, it's one entity, it's obvious. But if you want that, I think you are asking to write this way. A bar plus BC bar. But if you want, you can put brackets. Otherwise, that if you, without having a bracket also, there is no harm. This one, you can see this is A and this is B. Because of that, here we have AB and this is C. Then from this gate, we are receiving AB exclusive O between C. And this is the one for this input. And here, this is B and this is B bar. And we are taking AND operation between these two. Then result will be AB exclusive OC is one input. The other one is B bar. If you want that, if you want to put a dot here, then you can write this way also, but it doesn't matter. Without having a dot or having a dot is no problem. Both are same. Okay, now when you have a circuit, when you have a circuit diagram like this, now you know how to write output equation. Or this is the Boolean output equation of this circuit. Okay, these are Boolean output equations of the circuit. Okay, this is the Boolean output of equation of this circuit. This is the Boolean output equation of this circuit. Okay. Now you know how to write an output equation when you have a circuit. Shall we try this reverse? This is, can you draw a circuit for this one? Maybe do we get the last question? I think do we get questions of 3 inputs to 1 logical device, like ABC inputs given to 1 and O gate and so on? Yes, definitely. You will have that. Samudhi, that here some of these things that when you answer the question, when you draw the circuits for these problems, that you will realize that this type of gates you will have.
මේක එන්නේ ගන්න කිව්වේ මේක
Yes, Sandhuri, that we have three input AND gates. As I mentioned very beginning, AND gates, the minimum they should have two inputs, and then the maximum number of inputs are not, there is no limit theoretically. AND gate can have many inputs, maybe more than two. Any number is okay. 3 input and 4 input, 5 input, maybe 100 input AND gate maybe also theoretically there, but practically we don't have. But no problem that for the diagrams that you can use any number of inputs having for this AND gate or OR gate. It doesn't matter. NAND gate and NOR gates also same. Okay, here we can draw the circuit. We need 3 variables here. Starting from A.
Sir, can you show the seventh one again? Okay, sir.
Then here you can see that 3 variables are there, A, B, C, and we need A bar. Then we can make A bar, putting a NOT gate here. Now we have A bar. Another one we want to make, when you consider this term, we need a BC bar. We have to make BC bar, and we can make BC bar, putting a NAND gate here. Now this is BC bar. Then after that we can combine this one with another AND gate. To receive this one. Then here we have A, this is BC bar. Then this A, BC bar we can make. The other one, this one, A bar B we want to make. Then we need another then we have to have another 2 input AND gate here. Then this 2 input AND gate with this one we can here we have this. Can bring it A bar here and B is here. We can take B. Then here we have A bar and this is B. Because of that, this term is A bar B from this AND gate. To combine these two terms, what do we need? One OR gate. 2 input, 1 OR gate we can take like that. Then finally we have the result F. Okay. This one, we have 4 terms. And what do you need? A, B, C, D. We have 4 variables here. A, B, C, and D. Okay. Then first we want to D bar we want to make. Then shall we make this one first? We need D bar. Then after that, shall we make this term A, B, C bar? We can take 3 input NAND gate straight away. And this A, B, C, this one. Okay. To make third one, second term, we need another 3 input AND gate. This time we can take A here and C here and this D bar. And this is AC D bar. And we need another 2 input and gate to make AB. We can take A here and B. This is AB. And we want to make AD bar also. This one. And where is A? Here we have A. We can take A from this point and D. D is here. We need A, D bar, then this should be NAND. Okay. And after that, we need 4 input OR gate to combine these 4 terms together and to make this output G. Sorry. Sorry. Here, again, it's 3 variables, B and C. And we have to make B bar and C bar. First, we make this term A plus B plus C, that we need 3 input OR gate. And we can make A here and B. C. And then this is A plus B plus C. And we can take another one, another 3 input OR gate. Here we need A and B bar and C bar. And this is B bar plus C bar. And how do we combine these two? We need 2 input NAND gate. This is H. So when we are drawing, should it be drawn for the outputs to come as the order on the formula? No, it's not necessary. Can we show the answer for the sixth question again? Okay, the sixth one is this one. There is no order to be maintained. Or is it okay if the order is changed? There is no problem that you can have that your own order. But finally, you have to consider all the terms. Can we go back to the fifth one for a second? The fifth one is this one. Okay. Then final one, this one. We have 4 variables, A, B, C, and D. We want to make C bar, D bar separately this time also. Then we can make this C bar here and D bar here. Let's make this this term first. Then we need a 2 input NOR gate. This one. This is A plus B bar. Then shall we make this one? And before we make this one, that we want to make AB. Okay. Then we need 2 input AND gate to make AB here. A. And this is AB. Then we can take 3 input O gate. This one. This. Then here we have AB plus C bar plus D bar this term. Then we want to make NAND operation between these two terms. Then we can make another NAND gate here. Then we can break this one here. Then from this point, you will receive this is one term you are receiving from this N, and this is the other one. And because of this NAND, we receive this one. And this is the output we are receiving from this gate. Then finally, we want to make this term. We have this AB bar. Then this is AB bar. And after that, we have to combine this AB bar with the taking another maybe another 2 input AND gate, and we have to combine with D. This is AB bar D. Then we need 2 input OR gate. Now we have this term. Sorry, we can take this. It's okay. Then we can have 2 input OR gate like this. This is J. Okay, how to find the best way to draw the circuit? The less gates we use, the best circuit we draw, or the other way. Okay, Sansiloti, that we will come to this topic later on. For the moment, if you realize that that what I want to do here is that when you have this type of circuit, if it is possible you to write this output Boolean equation, that is one thing we need here. The other way, the reverse of that one, when you have this type of Boolean output equation, and whatever the way to receive these terms and this final output, if it is possible you to draw a circuit combining these basic 6 gates, that is the other one. Then both ways that you should be able to do. Then when you have output equation, you should be able to draw the circuit, and when you have the circuit, you should be able to write output equation. And those are the things that at the moment we are considering. And drawing these circuits with less number of gates, it may be the another topic. It might come later on. But for the moment, if you have realized these things, that is okay. Sansiloni, is it okay? Then, so is it okay to use De Morgan's laws to solve and draw the circuit? But it's okay. But for the moment, but we are not doing all these things. But we are, as I mentioned very beginning, we are starting from the scratch, and to understand all these topics for everyone, we are starting very simple form, and later on we can do the advanced things. And for the moment, what do we expect from at the end of this lecture is, at the end of this lecture today, if you have realized that when you have a circuit to write output Boolean equation and the other way around, and when you have the output Boolean equation, you should be able to draw the circuit for that one. That is enough. Okay, I'll upload this video. Maybe I'll upload this video to and send you to the link, and maybe then you can refer this link video later on. And in addition to that, this Word document also I can share with you, but you can refer both things together. I think I haven't put this videos for this circuit theory lectures also. I don't remember exactly that did I do that one or not. But, I'll upload those circuit theory lecture videos and the Word documents there. And this one also I'll upload these things to the internet, and I'll send you the link. But if you type, if you give me on the chat one of your batch representative email address, that I can send the links to you, then he or she can share among the batchmates those links. Then you can refer those videos later on. Is it okay?
Excuse me, sir.
Yeah.
Sir, is it okay to draw several ABCD terminals? That means without joining them?
Without joining them?
can't we draw several ABCD terminals? For example, sir, in the last example, there
Yeah.
is the yellow colored one and the orange colored one. So can't we draw separate AB terminals for the first one and separate AB terminals for the orange colored one? Can't be given
Uh,
marks if we draw separately?
But Putha, the practical situation, when you consider the practical situation, but these are, assume that these AB signals are coming from a sensor. That
Yes,
assume
sir.
that we want to make a circuit that those ABCD signals are coming from those sensors, and we want to make a security circuit for a room, and it may be the complicated conditions that owner has given to us. Then considering those things, that the type of complicated circuits we have to make, but practically those signals are coming from 4 ends. But it's okay that you can, for the moment, that for the drawing, is it okay to draw these things separately? But considering the practical situation and combining the practical things and the circuits, all these things together, it's better if you start all these things from a single point.
Okay, sir. That means, sir, if we draw separately, we are given marks, right, sir?
No. The marks receiving is something different. Okay, for the examination, that if you have done something like that, I don't cut your marks, but to be aligned with the actual things and what you are drawing, and if you start practicing the same thing with the practical thing, that is okay. But in your case, that otherwise, that when someone comes to you that asks a certain question regarding this one, that you have that knowledge and you will explain that person that this is the way start designing of a circuit, that this is the way you can do the truth tables and everything like that, you can explain. But when you when you give that idea, that person, that okay, the AB is having this one, actually, that you are asking this question separately, you can take AB again. This is the one. Okay, then you can draw this one here. But anyway, that when you consider the practical situation, that all these signals are coming from 4 common ends. This may be A, this may be B, and then here you have to combine this one here. Like again, that practical situation, these 2 A ends, you have to combine to one end, and that may be the final A.
Yes, sir. Thank you, sir.
Okay,
you,
then
sir.
I think go with this one. I think the problem may be that in your paper that you don't have enough space to arrange those things. That may be the question. But in the examination, I think if you do like that, I don't cut your marks, because I can understand your what the thing that you have done. If you have done those things, that it's okay. But practically, we can't do like that. If you do like that, anyway, that we have to combine those wires together. These are wires. But for the examination, don't get some kind of fear about this one, that I can understand what else you are doing, because that you are doing all these things maybe the first time, maybe the couple of times we have done previously also. It doesn't matter. Okay, the batch. Your
Excuse me,
coordinate.
sir.
Yes.
The resource book is same.
What do you mean? Resource book mean?
Same that you gave first semester book.
First semester, I gave the book for the circuit theory one.
Yeah, sir.
Okay, that for this one, that I'll find a different one, because that for the moment that I am referring actually, that frankly telling that this subject is I am the teaching. This is my 27th year. I am teaching the same subject. Because of that, actually, at the moment I don't refer any kind of textbook here. Okay, but all these things I remember by heart. But anyway, that I'll find a very simple book for you. Then you can simply understand all these concepts. That will let me have the couple of days. Then I'll give you some kind of reference books. That with that all these things have been explained in very simple manner. Okay, let me have this couple of days. That then I'll give you some kind of reference books. Okay, that you have sent me that this email address. I'll give you the link to this one, and then you can refer those things. I think I didn't put this circuit theory materials also. The previous batch I have placed all these things. I think I think still that you haven't faced a examination. I don't remember that I have, but anyway, that I'll check that one. Both videos I'll upload to the internet and send the link. Okay, I think we have almost taken more than 15 minutes from you, that you are having maybe another lecture maybe after that. Okay, thank you very much for being with me for this more than 2 hours. And I think if you have any kind of question, I couldn't mention that one at the beginning. I think you know that the way I have run this circuit theory lecture also, here also, that if you have any kind of question, it's very much like to answer all of your question. And I am very happy that you are turning on your mics and you are asking the question live. And the other friends of yours also, that you are asking many questions and typing all these things on the chat. I really appreciate that you are asking questions, and when you ask these questions, I think it's possible you can put to see all these questions to the entire batch. Then all your batchmates, that they can also see the question and answer I am given. This may be helpful to the entire community. Okay. Then because of that, I really appreciate that you are asking the question. That most of the time when I do the other lectures, that students are not asking questions. Here in your case, that you are doing certain things different. Okay, then thank you for that one. And anyway, next day also, that if you have any question, that beginning also, you can interrupt me at any time, ask the question, because this time is yours, not mine. I am here because of you. I am here. I can explain those things many times until you understand everything. Okay. With that understanding, okay, we can stop here today. And thank you very much for your time and the patience. And be safe and take care of yourself. We'll meet next week.
Thank you, sir.
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 Thank you, sir.